So here, given a Cartesian, so I'm given x and y. X is 1, y is 6. I want to find r and theta. Thinking back to the relationships between x, y, r, and theta, I remember that r is the square root of x squared plus y squared, and that theta is the arctan of y over x. So what do we get? Well, we just plug in our numbers. So r is going to be the square root of 1 squared plus 6 squared, which is 1 plus 36, or the square root of 37. So that's the exact value. So it does want an exact value for r, square root of 37. Theta doesn't say exact value. It's going to be the arctan of y, 6, over x1, which is just the arctan of 6. Now that's not a special value I know from the unit circle. So that is the only exact version of it, if this problem accepts exact versions. Otherwise, I got to whip that out on a calculator. So I'm going to check this, show desktop. And what is the arctan of, oops, can't spell, 6. And GeoGebra defaults to degrees. So let's check what my problem had. This was number 3. Yeah. If I click here, it says, oh, I can enter an exact value, mathematical expression, or I can enter a decimal value. Since it doesn't reference degrees or radians, it does right here. Oops, the 2 pi is implying I should enter a radian value. So in my GeoGebra here, I'm just going to adjust that. Instead of changing the conversion, I'm just going to multiply by pi over 180. And that will give me, even though it says degrees there, it's a lie. 1.406 would be the radian version of that angle right there. And I just want to check that out, see if it looks right. So if I plot the point 1, 6, I get that. And then since actually I'm going to get rid of this, since GeoGebra defaults to degrees, let's put back in degree mode. Oh, but over here it accepted radians. Okay, maybe we'll do radian mode here. Pi over 180. That's one downside of GeoGebra. Sometimes I find its degrees and radians are a little confusing. All right, so then if I do, what was the radius? Square root of 37, SQRT of 37, and then arrow out of that, semicolon to say this is polar, and then about 1.405, 1.406 should be that point right there. I'm gonna hit enter, and then it's calling this point D. See point D up here? If I turn point D off, underneath it is point C. So I did get the right one. And oh, interesting, GeoGebra did a little conversion for me of radians to degrees here. There's that 80 degrees we saw earlier. All right, so that looks like the right point. So again, read the fine print on these problems. Oops. And Desmos plotting points is a wee bit harder to plot points. Let's see, let's try that. I got Desmos over here somewhere. If I wanted to do a polar point here, so the rectangular one's easy, 1, 6. But the only way to do polar points is to use the r cosine thing. No, sorry. Yeah. That's a total pain in the butt here. Okay, we're not even going to do that in Desmos. It's too weird.